Hello everyone, this is Ms. Page, and in this lesson we are going to be talking about how to find zeros using our algebra skills for the cubic and quartic functions we have been graphing in the past couple of lessons. Here we see our two forms of here's our cubic function with our either a or 1 over b parameter in our h and our k, and then our quartic function. We can have both a and 1 over b, but when we graphed, we had only one. How complex the function is depends on how many parameters there would be. For a cubic function, there will be for sure one real zero when it has this particular form. We see that here. This is the type of graph that we got where we had this type of curve. For a quartic function of our transformation form, we can get either two zeros that are both real, rational or irrational. We can get no real zeros, or we can have exactly one real zero if the vertex of the curve is on the x-axis. All right, here we're looking at a reminder of, remember that when we are doing our undoing algebra, that we want to do in the reverse order of operations. So we want to undo addition or subtraction outside parentheses first. Then we want to undo multiplication or division outside parentheses. We want to undo exponents outside parentheses, and then we'll undo everything inside parentheses using that same undoing order. All right, here is our first problem. Our job is to find the real zeros, so rational and irrational of this function. We have a cubic function here. And then we're to identify those real zeros as either being rational or irrational. If we end up with imaginary zeros, anything involving our imaginary unit of I, of course, we will not include those in our final conclusion. All right, so what we know is that zeros are found or exist when a function intersects the x-axis. Points on the x-axis have a y value of 0. And in a function, the function notation such as this f of x represents our y. So this has a value of 0, and we are solving for values of x that would create that y value of 0. And that's what we mean when we say what is the zero of the function. So undoing addition or subtraction outside the parentheses first. We would undo this subtraction and add 6 to both sides. Then we would undo this multiplication times this 3. We're again working in the reverse order of operations. We divide both sides by 3. So now we have 2 equals this quantity cubed. Now we would undo the exponent that's outside the parentheses. And to undo a power of 3, we have to do the root, remember, with the index of that value. So what I'm looking at here is undoing this with a cube root. So I'd have the cube root of 2 equals the cube root of this quantity cubed. In this case, what's going to happen is that the cube and the cube root would undo each other like all inverse functions and leave us with x minus 4, the quantity in parentheses. The cube root of 2 cannot be simplified over here because there is no number times itself 3 times that equals 2, no rational number, and so this remains the cube root of 2. Then we would undo this subtraction and add 4, and that's a rational part, so we're going to put that in front. And so that is going to give us x equals a positive 4. And then since the cube root of 2 is positive, that would create a plus in front of it. So we get 4 plus the cube root of 2. This, remember, would be the standard form of that expression. Rational part, then irrational part. And that then would be our 0. So our conclusion would be that the 0 is equal to 4 plus the cube root of 2. And because it involves the cube root of 2, this would be an irrational value. And that finishes up both parts of the problem. All right, let's take a look at another problem. So here's a similar one. Here we have a y equals instead of an f of x equals. It is also a cubic function. So to find the zeros of this function, we're looking at understanding that we're looking for values of x that create a y value of 0. We would again do the reverse order of operations. So here I would undo the subtraction again first, adding the 27 to both sides. This gives me 27 equals negative x cubed, which means again negative 1 times x cubed. So now I am going to undo that multiplication, dividing both sides by negative 1. Give me negative 27 equals x cubed. You might have wondered if we could have added x cubed to both sides up here in this first step, and we could have. Adding x cubed to both sides would have also given us x cubed equals negative 27, just with the x cubed over on the left side. So now we're going to undo sorry about that. We are going to undo that power of 3 again. So we're going to take the cube root of negative 27 equals the cube root of x cubed. And on our x side, we are looking at the cube and the cube root, again undoing each other, and that's going to give us x. Here, be careful with this. This is not imaginary because it's a cube root. Remember, negative numbers times themselves 3 times will give us negative numbers. So there is a negative number times itself 3 times that will give us negative 27. The question is it rational or irrational? And in this case, it's rational because the number is negative 3. And so that then tells us that negative 3 is our 0. So our 0 is equal to negative 3. And as I mentioned, it is a rational number. All right, let's take a look at what's next. Here's a practice problem. You should pause the video now and give this one a try on your guided notes or a piece of paper, wherever is best. All right, let's take a look and see how you did with this problem. So here is the solution or answer. So here is our algebra. Progressed through, we end up with an x value of 1, which is a rational number. So our 0 is 1, and it is rational. All right, here we're back to another example. We want to make sure we do definitely put this one in our notes. We are still looking at a cubic function here. So we would begin, of course, by letting our y value become 0. Then again, we work in the reverse order of operations. So we are going to undo the subtraction, adding 25 to both sides. Then here we recognize that we have to undo the multiplication between the 1/5 and the quantity cubed. So to undo, it would be like, remember, dividing by 1/5. The rule for division by a fraction is to multiply by its reciprocal. So the easiest way to undo this is to multiply by the reciprocal of 1/5, which would be 5. So this gives us 125 now equals x plus 2 quantity cubed. By the way, in case it has not become clear or was not made clear, this is definitely a no calculator type of problem, so you should not be using a calculator for these problems on your assignment. We're now going to undo our power of 3, so we would take the cube root of both sides. Cube and cube root would cancel. The cube root of 125 would be 5. 5 times itself 3 times being the 125. And then we would undo this addition that was inside the parentheses, subtracting, and that gives us x equals 3. So in this case, we have a 0 that is equal to 3, which is, again, another rational number. So we make that statement. All right, let's see what's next. So here's a practice problem. Again, you should pause the video to try this one and test yourself, making sure that you can work through it correctly. All right, let's take a look at the result here. Here we go. So now you can see the progression, adding 6, multiplying by the reciprocal of -1/3, which is -3, then taking the cube root of both sides. The cube root of -18 is not a rational number, but it is real. So this has nothing to do with I, but it is irrational. There's no integer number that's going to give us -18 when we multiply it times itself 3 times. So it just stays, notice, the cube root of -18, and it is irrational. One thing I want to point out to you, with our cubic functions that exist in this transformation form right here, the one that we've been graphing from, you should never be concluding they have an imaginary solution. Going back to the concept portion, remember, those cubic functions always intersect the x-axis once, and that means there's always a rational or irrational zero. No imaginary zeros for these. All right, let's take a look at this one. So in this problem, we are looking at, so d of x, another power of 3, so another cubic, so d of x would be 0 to find the 0 of the function. And this time, all we would do is start by undoing our power of 3, because it's the thing on the outside. There's no addition, subtraction on the outside. There's no multiplication on the outside. So we're going to take the cube root of 0 and the cube root of our quantity cubed. The purpose of this example is to make sure that our number sense is clear, that we understand that 0 times itself 3 times is going to be 0. So this simplifies to just 0. And then here our cube and cube root cancel, giving us 2x minus 7. Then we would undo the subtraction, adding 7 to both sides, and then divide by 2, and we get x equals 7/2. So that then tells us that the 0 of the function is 7/2. If you want to, you could write it as 3.5 or 3.5, but that's not necessary for this problem, and it is a rational number. All right, let's see what's next. Here's another practice problem. Pause the video, give this one a try. All right, let's see what the result is. So here, this one, we have to subtract the 9 from both sides and then undo this multiplication by the 3/2 by multiplying by its reciprocal, which is this 2/3 right here. So we're taking 2/3 times that -9. And you can either multiply straight across, giving you -18 divided by 3, which is -6, or you can do the cross canceling, giving you 1 and -3, and -3 times 2 is -6. And then we have to take the cube root of both sides to undo the power of 3, and that gives you the cube root of -6. So hopefully this time, if you said imaginary in the previous practice problem, remember this is irrational, not imaginary, because it's a cube root. All right, let's see what's next. All right, so now we are to problems where we have an exponent of 4. And one thing I want to talk about, we have dealt with the square root property, which says that if we take the square root of both sides, that we have to include a plus or minus in front of the square root of the number portion. That is true for fourth roots also. To undo a power of 4, we have to do a fourth root, and it will need a plus or minus. We have to remember that here too. It's only on even roots, in case you're wondering why we didn't do it with the cube root. Because when you raise a negative number to an even exponent, you always get a positive number, which is the same value as the positive value raised to that exponent. So if I take -2 to the 4th power, I get positive 16. If I take positive 2 to the 4th power, I still get 16. And so I account for that in my algebra solving by including the plus minus, which gives me the positive and the -2 as my answers if I were solving back, doing my reverse, undoing algebra. All right, so here I would let my m of x be 0. So now I'm going to undo this subtraction, adding 32 to both sides. Then I'm going to undo this multiplication, dividing by 2, and I get 16. Now I'm going to undo my exponent. So I have to take the fourth root. Now on this side, I'm just taking the fourth root of x plus 1 to the fourth power. But on this side, I have a plus or minus the fourth root of 16. So here our fourth root and power of 4 cancel, giving us x plus 1. Should be an equal sign in there. What times itself 4 times equals 16 is 2, but it could be a negative 2 or a positive 2. You might recall we had to split them at this point in other problem solving of this similar to this, because when we subtract 1 from negative 2, it's different than subtracting it from positive 2. We don't get opposites. We get a negative 3 and we get a positive 1. So we have two zeros in this case, negative 3 and 1, and they are both rational. All right, let's see what's next. Another example here. So here we're looking at, again, power of 4. And we begin to find zeros always by letting our y or function value be 0. So that gives us 0 equals negative 2/3 x to the 4th minus 10. So I'm going to undo this subtraction and add 10 to both sides. So now I have to undo this times the negative 2/3. So that means I'm going to have to multiply both sides times the reciprocal of negative 2/3, which would be negative 3/2, or negative 3 over 2. Any number times its reciprocal is always equal to 1. And then I have to multiply the 10 times the negative 3/2 also. So this is 1. 1 times x to the 4th is x to the 4th. And over here you can look at it as negative 30 divided by 2, or you can look at it as reducing and then negative 3 times 5. Either way, you should come up with negative 15. Now I'm going to take the fourth root of both sides. Now this one, we get plus or minus the fourth root of negative 15. There is no number, no positive number times itself 4 times that can ever be negative. There's no negative number times itself 4 times that could ever be negative. This is definitely not a real number. So remember that we're only finding real zeros of our function. This is not real, therefore our conclusion will be no real zeros. And this is the type of graph or function that, if this was my x-axis, it would actually look like this, because it has a reflection across the x-axis, but with that negative on that 2/3, it does not intersect. All right, let's take a look at what's next. So here's a practice problem. Please pause the video and give this one a try. All right, let's take a look here. So hopefully when you divided by negative 6, you said that 0 divided by negative 6 is 0. The fourth root of 0 is still 0, so you end up with just 9, which is a rational number. Let's try another one. Here you go. Pause the video. All right, let's take a look at this one. So we would undo the subtraction first, giving us a 4, then undo the multiplication, multiplying by the reciprocal of 5/4. 5/4 times the 4 would be 20 divided by 4, or 5 times 1, which is 5. 4th root of 5, that's fine, because 5 is positive, so it's not rational, but it is real. And you get the plus or minus, hopefully you remember that. And then we would subtract the 2 from both sides, giving us these values. So make sure you separate them. So we have a negative 2 minus the 4th root of 5, and a negative 2 plus the 4th root of 5 is our zeros, and they are irrational because of that 4th root of 5 part. All right, that is the last problem in this lesson. And if you have any questions, please do let me know. Have a good day.